Okay. All right. Okay. Let's see. We're going to share my screen. We'll start off here. I'll check attendance again and around the 15-minute mark. Yeah, no real announcements other than, we can anticipate exam 3 to become available this Sunday. Let me check and make sure I have that scheduled for you guys properly, because it was for one of my classes. So exam 3, yeah. So it's scheduled for this Sunday. So exam 3 is scheduled to become available this Sunday. It's over chapter 2, so sections 2.1, 2.2, and 2.3. It'll be due the following Sunday at 11:59 p.m. And that's essentially it. We're pretty much at the end. Like, we're rapidly approaching the end. We're gonna, so we're going through the material for chapter 2 today. So then all of next week we're just going to devote that to exam 3, right? So what that means is I'll be on the call to kind of like answer questions. It'll really just be to log in just to get your attendance credit. And if you don't have any questions you're not obligated to say, that'll be next week. But you can ask me questions about anything that's on Pearson, even your current live exam. Can't think of anything else. I feel like there was something else, but I can't think of what it is. So I'm just going to go ahead and take some time and get through as many homework questions as we can from section 2.3. And what was kind of working for me earlier. Okay, yeah, let's do that. So I kind of shrunk the size. I'm going to reposition this a little bit. Kind of like that. And then I think over here, I just need to like zoom out some. And then I think this like that. Okay, that's better. It's not all the way there. That's fine. Okay, that's what I needed. I think that's all the stuff I need. Okay. So I kind of changed up the presentation just to style a little bit. I just been writing out the questions for essentially. So for instance, we're going to start with question 1. This comes from section 2.3, question number 1. And I'm just going to abbreviate it as basically we're just doing synthetic division. Okay. We have x to the 5th plus 2x to the 4 minus 7x cubed plus 2x squared plus x minus 1. And we want to divide that by x minus 1. Okay. Now, one thing is, in order to do synthetic division, we do have to divide by a linear binomial. We are dividing by a linear binomial, so we can do synthetic division. When we go to do synthetic division, into the chair goes the 0 of the linear binomial, right? So the 0 of this guy is going to be 1. So we put 1 in our chair, and then we take our coefficients. We got to be on the lookout for when we need placeholders. So we go 1, 2, -7, 2, 1, -1, okay? We started with the degree 5. So at this stage, the degree of the polynomial is 5, so we need 6 coefficients. 1, 2, 3, 4, 5, 6. So we're in the clear. So that means we've covered every power. Okay. So then synthetic division, the first coefficient just comes down. On a diagonal, we multiply. Vertically, we add, we multiply, we add, multiply, add, multiply, add, multiply, and add is -2. Okay. And again, I'll check Zoom around the 15-minute mark for anybody that's late. Okay. So the quotient that we got, so we started with a degree. Let me see. I need this to kind of, yeah. We started with a degree 5. So at this stage, we're now at a degree 4 polynomial. So then our quotient ends up being x to the power of 4 plus 3x to the power of 3 minus 4x squared, 4x squared minus 2x minus 1. And our remainder we got was -2. Okay. Let's go to the next question. Synthetic division again, okay. And again, as usual, if anything is not clear, you just stop me, right? Feel free to unmute yourself or type in the chat. The best way is to just unmute yourself, but I do check the chat periodically. This is question number 2. This comes from section 2.3, question number 5. Again, basically it's just synthetic division, okay? We got this x to the power of 6 plus 5x to the power of 4 minus x cubed plus 6 divided by x plus 2. Okay. So kind of a repeat, in order to do synthetic division, we need a -2 in the chair. Now it looks like we're going to need some placeholders here because we're missing some of the powers. So we need to just catch those placeholders. Like we're missing power 5, so we need to put a placeholder there. Then we got this 5, -1. It looks like we're missing power of 2 and power of 1. So we need 2 more placeholders and then the constant term, okay? We started with a degree 6, so we should have 7 coefficients. 1, 2, 3, 4, 5, 6, 7. Okay. So then the 1 comes down. On a diagonal, we multiply, we add, we multiply, we add, we multiply, we add. 38, right? Positive 38. Negative. If that were 40, that would be what? Negative 80. So then negative 76. That sounds good. 140 plus 12 is 152. And then it looks like we finished with 158, and that's our remainder. And then we started with the degree 6. So then at this stage, we should be at a degree 5. Okay. So we go here, we got x to the power of 5 minus 2x to the power of 4 plus 9x to the power of 3 minus 19x to the power of 2 plus 38x minus 76. And then the remainder is 158. Okay. Let me just check on you guys in Zoom for a quick moment. Okay, we got some people hanging out. Oh, no, these are, let me get these guys. Okay, that's the one I was looking for. This one. Okay. This one. And this one. All right, let's keep the party going. Share the screen. All right. So that was question 2. Let's go on to question 3. Okay. So then for question 3, This comes from section 2.3, question number 7. We're basically saying asking us to use synthetic division. Okay. We have 8x cubed plus 30x squared minus 4x plus 1 when it's divided by x minus 1/8. Okay. So if we're doing synthetic division, the 0 of the linear binomial goes into the chair. So that means 1/8 goes into our chair. We take our coefficients of 8, 30, -4, and 1. Okay. Notice we started with a degree 3, so we should have 4 coefficients, 1, 2, 3, 4. So we're in the clear. We don't need any placeholders. The first coefficient just comes down. On a diagonal, we multiply. We get a 1. Oh, this is getting nasty, right? So then we get 31. Diagonal, we multiply. Dang, that was a 32. Well, let's just go with it. We're going to get what? 31/8. 8 times 4, -32. So then those add up to -1/8. We multiply, we get a -1/64. So we finish with 63/64. Okay. So then we started with a degree 3. At this stage, we're at degree 2 plus this like that. Okay. Then let's go ahead and answer the question. The quotient looks like it is 8x squared plus 31x minus 1/8. Okay. And the remainder is 63/64. 63/64. Okay. All right, let's keep going. Next question. Synthetic division. Okay, so they just asking us to do synthetic division. That's enough space. Okay. So this is question 4. This comes from section 2.3, question number 9. I'm going to abbreviate it as basically we're just doing synthetic division. We got 10x cubed minus 5x squared plus 2x plus 8 divided by x plus 3/2. Okay. So conditions are satisfied. We're dividing by a linear binomial. So the 0 of the linear binomial goes in the chair. So then we got a -3/2 in the chair. Okay. When we take our coefficients of 10, -5, 2, and 8. Okay. Notice the degree of our polynomial is 3, so we should have 4 coefficients. We do. So our placeholders are accounted for. The first coefficient just comes down. Let me see, 5 times 3 is a -15. That's going to be -20. That's going to be 30, 32, 16. Let me see. 16 times 3 is 30, and 18 is 48. So -48. Looks like the remainder is -40. Okay. We started with a degree 3. So at this stage, we're at degree 2. Okay. We have everything to answer the question. So our quotient looks like, and notice that all of these have been the same thing over and over, just with different numbers and like minor changes. 10x squared minus 20x plus 32. And the remainder is -40. Okay. Let me check on you guys in Zoom. That's the usual suspect. All right, let's keep it going. So this is question 5. Okay. This comes from section 2.3, question 11. So basically, it's still synthetic division. So we're basically we're finding a case, or we're basically, this is the remainder theorem. We're evaluating when x is 3. We could just plug in 3 and get the result, or we can do synthetic division. It should be easier to do synthetic division. Let's see. X to the power of 3 minus 5x squared plus 10. Okay. So basically, we put in 3 into the chair. Our coefficients are 1, -5. Let's see, 3, 2. We're skipping power of 1, so we need a placeholder. And 10. Okay. 1 comes down, 3, -2, -6, -6, -18. All right. We get -8. We're starting with a degree 3. So at this stage, we have a degree 2. Okay. All right. All right, let's go with it. So they want us to evaluate P of 3. So then P of 3 is going to be a remainder, which is -8. It's basically an application of the remainder theorem. So the remainder theorem, same kind of deal, right? That was 5. Let's go to question 6. 2.313. Okay. I'm going to abbreviate it as synthetic division plus remainder theorem. Okay. So we have f of x equals, we got this x to the 4 plus 4x cubed plus 5x squared minus 2x minus 6. And they're asking us to evaluate f of 3. So we could just plug in 3 and get a result. Or we can just do synthetic division. 1, 4, 5, -2, -6, all right? We started with the degree 4. We should have 5 coefficients, all right? I think we're in the clear there. So then the 1 comes down, 3, 7, 21, 26. 75 plus 3 is what, 78? 76. 210 plus 18 is 228. 228. And it looks like we finished with 222. 210 plus 18. I think we're okay there. Okay. So then we started with the degree 4. So now we're at a degree 3. Squared, 1, and a constant. Okay. So then x to the power of 3 plus 7x to the power of 2. Oh, okay. Plus 26x plus 76. Oh, duh. Sorry. Remainder theorem. They don't want all that. They just want the remainder, which is 222. Okay. Check on you guys in Zoom. Cool. All right. So, because I'm not going to sit here and talk to myself, you guys are welcome to watch one of my other recordings from today. For this class, for you all, I will watch by 9 o'clock, really. By 9 o'clock in conjunction with my 2 o'clock, right? The 1 o'clock is not you guys. But I'm the only one here, so we're going to go ahead and end the session here. From one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.